Hello, everybody in attendance. Thank you for coming to the AIAA Space Resources webinar series today. My name is Jared Longfox. I'm based at the University of Central Florida. I'm the chair of the Education and Outreach Subcommittee of the AIAA Space Resources Technical Committee. We host these webinars to be for anyone K-12 through seasoned professionals in the field of space resources, as well as just general public enthusiasts. We do, and I will be sending links in the chat for this later, but these are recorded webinars, so this will be up on YouTube within the next couple of days on the Space Resources Webinar YouTube channel, which I will again provide a link for. And we do also keep slides from most of our talks on the AIAA Engage repository, which again, I will link later towards the end of the chat, or the end of the webinar. Today, we're fortunate enough to have Wesley Fuhrman and Milena Graziano from the Johns Hopkins University's Applied Physics Lab, Lunar Surface Innovation Initiative, and Lunar Surface Innovation Consortium. I'm not going to steal their thunder. I will let you guys take it away. I will be turning off my camera for bandwidth issues. But like I've said, I'll be lurking in the background. If you need anything, just speak up. Folks, if you have questions as we go here, the attendees should be able to punch in questions in the Q&A feature on your bottom ribbon. You may need to click the three little dots that say more, and then a menu will come up, and there's a speech bubble that says Q&A. You can type things in there as we go. There's also a webinar chat that you can type things into. If you punch things in the chat, I would request that you send it to either hosts and panelists if you want it to go to me or Milena and Wes, or to everyone if it's a community-wide announcement. I do know we have some other LSIC representatives in here. LSIC representatives, please feel free to use that chat to paste any links or information that you see as we go. I think that's probably just about enough from me. So without further ado, Milena, Wes, please take it away, and thank you for lending your time here.
Thank you so much. We are very excited to be here with everybody. What a time to be part of this and then talking about all of the things that have been happening with the moon and with initiatives about the moon. So saying to the moon with LSIC, this is the right time to be part of LSIC and making sure that you are in tune because there is a lot going on. So first, my name is Milena Graziano. I am the director for the Lunar Surface Innovation Consortium. I have been a cool 2 months into the role. Yeah. It has been incredible. And I have been very fortunate to be part of LSIC since probably 2021, when I had worked with the extreme environments team, that you guys remember that group, and now as part of the cross-cutting capabilities. And I am trained as a materials engineer, and I space environmental effects. So that's me.
That's Milena.
That's Milena.
I'm Wes Fuhrman. I'm the lead for the Lunar Surface Innovation Initiative. We'll talk about how these things all kind of work together as we go through our presentation, so you all can understand how it all works out. So I started with LSII and LSIC back in 2020. So from the first kickoff event, which was 2 weeks before the pandemic happened.
Oh my goodness.
It's amazing to see, some of the ideas that were just, folks had on napkins at the time have now flown to the moon. And yeah, bear with us. We are processing all the events the last couple days.
It's been a roller coaster.
It's a roller coaster.
But it's an exciting roller coaster. I mean, this has been the fact that ignition happened this week. That is the biggest NASA announcement that has happened probably since the initiation of Artemis program. That was what, 2017?
Yeah.
So yeah, it's huge. We have a lot to look forward to.
Yeah.
So I guess we were gonna start with like why the moon, and it feels like Jared Isaacman and everybody else did that for us this week. But
right.
We really want to make sure that we present to you all what are these administration's space policy priorities and how do they relate them to the work that the Lunar Surface Innovation Initiative and the Lunar Surface Innovation Consortium are doing. So one of the biggest things is asserting American leadership in space. We want to make sure that the United States has a role and has a leading role in all of these initiatives about the moon, cislunar space, any of these exploration goals that other countries are also having, making sure that US has a big position with that. And I read today that over 90 countries have now a space program, which is fascinating. It's really wonderful. And so the United States continuing to be a lead, making sure that everybody collaborates, and also making sure that humans, and we have a place there to return on the lunar surface, is going to be really important for the United States. And now that we're returning humans, that continues to be our goal for 2028. The Artemis program is going well. The launch of Artemis 2 is next week. What? It's gonna be so incredible. So everything is just proceeding as planned. But as with these big programs, and now Ignition announcing the moon base, and now really have a plan, a solid plan for a moon base, for the United States to have a moon base. I just think that's incredible. But like every large program, you need to start with some initial elements, right? Initial assets. And so part of the executive order from ensuring American space superiority was to making sure that we establish these initial elements on the lunar surface for a permanent lunar outpost. We had 2030 when this got released in December, but now
accelerating. 2027 is breaking ground.
Right.
I think a lot of people are still trying to decipher just what it means for each one of these elements, each of the phases of that. I think we have our thoughts on it that we're going to share, how we've developed it through LSII. And but again, all of these things are subject to change pretty dramatically.
Very dynamic moments in time, but very exciting. Very exciting. I mean, the fact that that is now something that is planned for, and it matching the executive order, I mean, even since the leaked Project Athena, just the vision of the administrator really trying to put it in execution is just really wonderful. I would be remiss if I don't mention that nuclear power component of all of these goals, and enabling the near-term utilization of space nuclear power on orbit, on the moon, and having that lunar surface reactor ready for launch by 2030.
Yeah, that's a detail. There's a lot that will change on these things, but it was consistent that even though in the release of the last couple of days, they presented a vision for a nuclear electric propulsion system, that then the surface mission, whatever the reactor that comes to the surface, could build off the tech that's developed for that. And I know that the space resources community has been especially interested in this, and because a lot of what you would like to accomplish with ISRU and C2 resource utilization does require those large power levels. So the process of getting there is being laid out now. It's exciting to be kind of a part of that. One thing I do want to say is that as a part of LSII and LSIC, a lot of what we do is hear from the community and try to bring this back out. So, please feel free to use the chat and the Q&A, get those questions, get those comments to us too. You can process with us.
As we are processing it too. I mean, when we were making these slides and just seeing how everything has just aligned so well with all of these priorities, all of these initiatives echoing each other, it's just been really incredible. This initial lunar infrastructure that we'll put there will start doing some exploration, and hopefully some ISRU activities are going to also happen, laying the foundations for that lunar economic development. So commercial is going to have a big role. Government's going to have a big role. All of these really important participants working together to make this a realization. And we cannot forget about Mars, because this is our proving ground for that big goal, which is our Mars exploration in the near future, hopefully. And as we're all here, and thank you so much, Jared, for giving us that messaging, we really want to make sure that the activities that LSIC does, LSII does, but the nation is doing, inspire the next generation of American explorers, or children, grandchildren. I mean, I consider myself that next generation.
That's right.
Yes, it's just really exciting. So I think starting with this ensuring American space superiority executive order, and now seeing the transitions, just absolutely baffling. And now, the NASA Authorization Act.
So there's a long process between executive order and, or the vision to put something on the moon and then actually delivering it to the lunar surface. One thing that has given us A lot of details in the starting with the executive order, very high level. NASA Authorization Act has some more details, even more details through the last couple of days with NASA's Ignition event. But they were calling out several things already in the Authorization Act for NASA to take on. So very clearly, everything is focused on the lunar surface again, and looking at it kind of holistically. So what can we get out of it, not just for the science that it offers, but the economic, technological, security, social benefits, societal benefits of doing these things on the moon. And the approach that's rolling out now is very much we're going to learn what's possible on the moon and then be able to utilize it and execute on it. So it's very exciting. I really like the approach.
I know. And I want everybody to remember these key messages that are in kind of amber color, if you can see them.
Yeah.
Exploration of the lunar surface, it's like check
Check.
with LSIC and LSII. Infrastructure and technology,
That's been
check.
our bread and butter for forever.
One interesting thing is the continual cadence of those low-cost robotic lunar landing missions. We've been talking since CLIPS, right?
Yeah.
Since CLIPS started, we've always
And how
had.
can we even expand the ability to get back to the surface? Because access is so critical.
Right.
Yeah, keep going.
And then establishing a lunar base is now super mega check because that's what we really want.
Yeah.
So super excited about how everything is just coming to fruition. And then really looking at these precursor surface missions and demonstrations. And now with the ignition announcement and some of the work that LSI has been doing, all of these things just very well aligned with the work that our consortium and the initiative have been really working towards. So super, super exciting.
Very exciting.
Now, and let's not forget, continual cadence of low-cost robotic lunar landing missions. It used to be like, okay, we're gonna do 4 or 5 in a year.
No, 1 or 2.
After this week, how many are envisioned for?
Almost monthly.
Almost a monthly cadence of lunar landings.
But also not just ones that are going to live for the brief period that they're there, that have the ability to kind of bootstrap and grow into a base, which we'll talk more about.
Right. No, it's just incredible. Yep.
So the Ignition event, and this is, Milena and I are talking these things, but I strongly encourage all of you to go and look at the actual documents. You can watch the Ignition event on YouTube as well. It's all recorded, about an hour and a half, I think, on the moon base. Really, really fantastic stuff. So here's a laydown, just kind of a vision for how these elements are coming together on the lunar surface. And as Milena was saying, it's a series of these transformative initiatives that really are taking that steps to execute on the national space policy. When I'm looking at this picture here, I'm seeing elements across the board that are going to matter. And I'm thinking about just how we're going to get to this cadence of nearly annual missions, nearly monthly,
not annual,
that we're putting
monthly.
down. Like, how are we going to make sure that we've got the payloads that we need, that we're maturing the technology so you can get to all of these things?
And look at all of the technology in this one snapshot of the lunar base. Look at that cable going from one asset all the way to the other. I mean, think about doing that on a planetary body that is not Earth. It's just incredible.
And even to get to this picture, there's going to be a huge buildup of these. So one thing that I've always been thinking about, as for LSII and LSIC, we are thinking about the earlier side of technologies. So what is getting developed in the pipeline so we can get through and develop them? We're going to be blowing through those payloads. If we're landing on the moon this often, we're going to need ideas for how we keep that pipeline going, because it takes a while for those technologies to mature, to put the work in, so that they can be ready to fly in space. So we're going to have a whole new avenue where instead of a kind of a log jam at the end of that technology development pipeline, it's going to clear that out, and we're going to need more things coming in, keep that conveyor going. So,
not only that, but all of the technology development time that usually you spend several years maybe doing that, with this now accelerated pace, we're going to have to just do this very quickly, turn around technologies very quickly, accept some risks very quickly, and just start deploying the technologies on the moon.
Exactly.
And just wish them well and get some results. So it's just really, really exciting.
Yeah, this is structured in, again, you can go back and watch it, but it's structured so that every asset, every kilogram, all the lunar exploration that we're doing is focused on building out this moon base. So you'll see a little bit later, we've talked about this under LSII and LSIC for a while, but how can you use some of those early CLIPS landings to get the information that you need to test out some of the early technologies too. And that's what phase one is out of their in their building a moon base. So that's where you're going to put a whole bunch of landers down. You know, you're going to accept a lot of risk, a lot of failure as you're learning to land close to each other, as you're testing out some of those key technologies. The next phase is where those elements, this is my read on having watched it, the next phase is where those elements are starting to have to come together and actually work.
Right.
So that by the end of phase two, you're ready to have a base that can serve beyond an individual mission and support the humans that will ultimately be arriving, I think at the end of phase two, they said, and then obviously throughout phase three, so enabling that long duration human presence. So this approach is much more incremental, and it's much more, we're going to learn by doing, because we've been to the moon a few times.
We did, but it was over 50 years ago.
But we haven't ever done the sort of thing where we land and actually go back and have to rely on
that is what is
previously
exciting.
placed elements.
Now there's actually a plan to not just go, hey, hello moon, bye moon. It's now, hello moon, we're here to stay, and look at all of these things. Oh my gosh, we're having all these assets coming in. Oh my goodness, it's just gonna be that exciting, that much activity happening in the very near. I mean, from now, I think when they were introducing ignition, 2027 is when everything's slated to begin.
Correct.
And it's just continuous landings, continuous assets on the surface, all the way through the 2030s.
Yeah.
So there is now
strong
not a hello goodbye.
Yeah.
It's a real good like hello, we're here to stay.
Yeah. And actually, just yesterday, there was a first logistics class lander that Intuitive Machines won a Eclipse award for. Their Nova D lander.
Right.
So that's super exciting. Like they're already, following that up, $180 million to IM, something like that. For them to develop a logistics class lander. And that's the sort of thing that you're going to need to do this.
One of the important things to mention now, and this is part of what the Lunar Surface Innovation Consortium and the initiative are really, this is their role, our role, is to make sure that we are getting feedback from the community, from the enthusiasts, from the scientists, from the technologists, from the engineers, from the students, academia, etc. We want to hear from you how this plan you believe can be executed.
Yeah.
There's going to be some limitations. NASA has recognized that. So there is an RFI right now for chain, what was it called? The limitations on the chain production.
The supply chain.
The supply chain, thank you very much. So NASA wants to hear some of those concerns and see how they can work around it and address them. They also want to hear is any concerns that you may have with this plan or any other observations that you may have for this plan. And LSIC is one of those venues that provides a way for you to provide feedback on all of these initiatives that NASA is presenting. Yep.
So what is LSII?
Oops, I said too much before this.
No, it's great. We'll just turn it all the way through. It's the whole point, right? So NASA's Lunar Surface Innovation Initiative, it's under NASA Space Technology Directorate, which is the area where these technologies are being matured, as I've been saying. And the role of LSII, this initiative, it's not a program, it's an initiative, because all of the things that it's tracking are scattered across a lot of areas of STMD. So LSII's role is to look across all of that and guide the investments across STMD to make sure that they're getting those needed. So to meet Artemis and sustained presence on the lunar surface. So since 2020, 6 years, probably I think it's on the order of $1 billion worth of investments that have gone towards maturing those technologies for that sustained presence on the lunar surface. So you can tell maybe that's why we're a little bit excited about it.
Right.
And LSII, it's working across all of just like it's a lot of different programs in STMD, it's also happening not just in one place, one domain, one sector, not even one location, right? It's across the country, across the world. Looking across industry, academia, government to develop the capabilities that we need. We tend to be a little bit more heavy on industry, I think 40 or so, 50%.
I have a chart for that too,
so
I'll give the
we'll
distribution. One thing to highlight.
Yeah, go ahead. Go.
One thing to highlight. I love that statement there. Maintain the pulse of external stakeholder community.
Right.
I mean, really, if we don't have a good sense of what our community can do and how they can contribute, NASA alone cannot achieve all of this massive work that they have just proposed. So LSIC enabling that through LSII is just really the most important thing that we do on our day-to-day. Yeah. So.
And what is JHU APL's role within LSII? So as I said, the initiative itself, NASA's initiative, is the broader organization of all of their lunar surface technologies developments, and JHU APL is the systems integrator for LSII. So we provide subject matter expertise for these lunar surface systems and technologies. We've got an enormous depth in lunar scientists. So if you want to know things about lunar science, please, we'll find you the right people.
Oh yes, we have tons of
amazing,
friends.
humbling numbers of
Well,
them.
I mean, to be fair, I am a materials engineer by training, and
Yeah.
I have learned so much from our lunar scientists and engineers that have been
Yeah.
working on LSI, that I've met on LSI and LSIC. So really, they are also fully available for conversation. They are part of our community.
They're part of the community, and they are, through some of the products that we create, and we'll talk about those a little bit.
Right.
If you need more things, we're happy to work on ways to get you those. So the systems integration role, we can provide subject matter experts, we can do technical analyses, we do some engineering as well to operate on all these technologies. And we also contribute to NASA's technology road mapping and support their reviews. All of those things kind of really serve NASA in our capacity here. And the biggest thing that we do under LSII is operate the consortium.
Yes.
Milena
and team.
Yeah,
Milena and team.
Very much a team.
We have a huge team, and we work all together to make. I like to say that we are making the community's dreams come true.
I hope so. My dreams.
But yes, I'm hoping that we continue to be that venue for communication between the community and NASA. I love when it says that executable strategy for development and deployment, because without that feedback, you really cannot plan how to do things. Yeah. And also that we are getting that feedback and not just staying with the feedback, we give it to NASA. And NASA is able to review that, is able to think about that.
Act
and then
on it. Maybe make a moon base about it.
We're not going to claim that the moon base came from LSIC, but a lot of people in LSIC were saying.
I mean, I think there is a response to what the community feedback has, and they're clearly listening to a lot of the community.
I'm really happy about that, because that means we've been doing our job now since 2020, despite pandemic. And, making it happen. So, please note, over 1,400 organizations working toward one goal. So if you don't think your organization is here captured, please join LSIC, because we want to get that number really high.
Yeah, everybody as a part of it. Yeah, so this is just some examples of some of the systems integration work that isn't the consortium. Supporting challenges, performing studies. We'll talk a little bit about the Lunar Infrastructure Technology Campaign, that particular study. But yeah, a broad swath of work that we do in order to help STMB make the best calls that they can, and in order to help the community best respond to those calls as well.
One thing is that we do not do any of these studies in vacuum.
Very great point.
Right? The community really is part of how we generate this. First, we identify the need. And the need is really relayed from community feedback. And then if we identify a need or an area that is lacking in terms of, let's do an assessment, let's do a state-of-the-art evaluation, then we do our work to do a system integration work and do the study. And then these studies are then shared with the community, and the community provides us feedback. We modify again. Some of them are part of the studies. So really, this is an iterative process between community, APL, NASA, etc. It's really iterative, which is really good. One thing I wanted to mention is that we have a webpage for Lunar Engineering 101. Lunar Engineering 101 was a suite of videos that we created to introduce the lunar surface environment to anybody that wanted to learn about it. We have the links online. Thank you, Anthony. And if you want to learn about dust, regolith, if you want to learn about the gravity, vacuum, the ultraviolet radiation on the surface of the moon, actual ionizing radiation of other kinds that can fry your devices and cause other sorts of issues, and then any other environment and environmental effects that can happen to hardware and systems that are targeted for the lunar surface. Lunar Engineering 101 is that resource that was created in LSIC and LSII to make sure that people can understand. And what is important is that once you understand the environments that you are going to target, you can design better, and then you can test better. And that is really the goal.
Well, and especially, as we're moving towards a rapid cadence, what are you going to test? How are you going to, where can you loosen things?
Correct.
One thing that I really appreciate about the Lunar Engineering 101 is that it's not just the environments, but also then what are the engineering implications of that, and then what are the follow-on references that you need to be able to go deeper as necessary.
And when we say references, there's a lot of references. If you go to that
Hundreds,
paper from IEEE Aerospace Conference, and we had it just every time that we were looking at a paper, we were putting it there. Why? Because we want you to know that we looked at other work and other experts that have been able to evaluate these environments for years. And so
find it.
absolutely.
Yeah.
So look at the paper, but also make sure you look at the references. And to me, they're kind of really exciting when you see these older papers about how they were. And now we're gonna go back. Maybe we'll have to write a new Lunar Engineering 101. I don't know. I mean, hopefully not terribly bad, because the environment shouldn't really change that much, but we're gonna learn more about geotechnical properties of the regolith. We're gonna learn some other things that are gonna be exciting to write about and comment on. And we also want to hear from you. What are some of those environmental effects and environmental things that you think about that could affect your hardware and you haven't really received an answer from anybody? Our community is able to support that as well. So so Lunar Engineering 101, make sure you visit that one.
Oh yeah, so just a couple examples of some of the work that's gone on from our ISRU team specifically. We won't spend too much time on this, but we do have some of the experts online. Maybe Anthony, you could put your email in the chat if you're open to that. But you know, we're all about bringing the community together, and one of the efforts that they've had pretty recently was understanding how to do that in action. So a collaborative systems interface workbook that shows you how these can come together, and using this design structure matrix. So Anthony is the one to talk to about a little bit of this.
Yes, make sure you get that email, the facilitator _ISRU@jhuapl.edu.
Yep. So that's one of the resources that we've taken on. You can also think about some of the studies that we do when we've identified that there's a potential issue or something that the community needs to know. So what I'm showing here is just one of the modeling water electrolysis. MSE is molten salt electrolysis, MRE is molten regolith electrolysis across different gravity levels. So if we're trying to create bubbles of oxygen off of the electrode in low gravity, and are they going to detach? What are the flow characteristics of this? So this matters a lot, because that's going to be your system's ability to work continuously, or even maybe work at all, is dependent on some of these properties, which you can't very easily get to the moon and test it out. So we've done some of that work, and you can follow up with these as well.
And then I mean, the goal really from this molten regolith electrolysis is to get oxygen, right? And metal alloys, but what is the goal with the oxygen? Once to extract it, what do you do with it? Right? It's a commodity it's a lunar resource, but what are we planning to do with that oxygen?
Well, that's a great question. Do we have the next slide on that?
Yeah.
I feel like you do. Oh, right. So not just what you would do the oxygen, but I think the commodity production and building out the ability to use these things. What are you going to use? Just where are you going to do ISU? So one thing that we've put together is this Lunar Infrastructure Technologies campaign concept. So this is, a little over a year ago when we put this campaign concept together, trying to understand what it would take to put these things together into an actual infrastructure on the moon. And you can see that we were looking at how you're going to make sure that you have the comms and PNT that you need, how you have the power that you need to perform operations, and then all of the supporting surface operations, which could be, regolith manipulation and so on. With the idea that this campaign could help secure a location, delivering some of that long-lived commercial infrastructure rapidly, and completing that minimum viable infrastructure in 2029, so you can then grow and build this incremental, bootstrappable infrastructure. So leveraging a lot of those commercial infrastructure. So this is, robotic moon-based development starting in 2027 was the plan with this concept. For the next slide.
Yep.
So if you want to think about how we structured this effort, we really wanted to get to the point where we're able to have multi-use infrastructure on the lunar surface. So like I said before, the only time we've ever done that before was Apollo 12 coming close to Surveyor 3, and it wasn't entirely clear that it was safe. So the ability to get those assets together in the same place on the lunar surface is like the first goal you have to define.
Can we appreciate how lucky Apollo was?
Oh my God, across the board.
I mean, really. they really were lucky on landing. Like, I mean, they had a lot
landing
of
was tough,
resources and they planned a lot, but it's just landing on the moon is not easy. So having this plan that lets you at least start addressing,
Growing.
let's start addressing how do we land and how do we get precision landing. Let's start addressing what are these assets that we need to get first. I think I really like the plan, and it really matches very well
It does match
with
very
what
well
is the
with
plan
the
right now
moon-based
with the moon base. Yep.
And one of the things that we really wanted to emphasize too, that in addition, you've got those core set of objectives that you have to make no matter what. But we recognize that there's technologies that need to advance for longer term exploration needs. And I think ISRU is clearly in one of those categories. You probably don't need it the second that you land, but you want to be able to have a path to where you can use that. So we developed this approach to also have what were called technology injectors, is what we called it. And these are the opportunities, the protected swap, the protected payload allocation, where you can check how you actually do surface modification, how you do power beaming, which is maybe a long one, how you do ISRU, especially for that scalable commodity production, where you want to do things at bigger and bigger scales, but you probably need to do some smaller scale things first to prove them out. We also consider to this process the commercial ecosystem objectives. So not assuming that you instantly have a closed economy that develops out of this, handful of missions, but that you're making sure that you're setting up these as explicit objectives so that you can make progress along those lines. And that allows you to make sure that you have the interoperability from the beginning, that you're considering things like how you would actually monitor and conduct transactional financial transactions. And then finally, on the backside of it too, one thing that we've recognized is that the kind of moon base that you want to develop doesn't happen with just one provider, right? There's a lot of people who are participating in this. And so you need to have an explicit objective for how you're going to share that community enabling information. So that was a part of what was baked into our series as well.
Very great.
And then, oh wow!
Oh, I love that.
That's very cool. I didn't realize we had a
We did not know that this like that.
So once we developed our campaign concept, we brought it to the community, as we do almost everything that we possibly can. We bring it to the community. So way back in September, which seems like a lifetime ago now, we had a commercial feedback session. It feels a bit like an industry day, but really an open dialogue with the community, especially the commercial participants, for how you're going to make this thing work out. We had, participation across the small players, under 50 people in your company, through to companies that are 5,000 plus, pretty even across that. So it gives you a nice platform where it's a little bit even. You're able to participate and be heard as well. I was blown away at how much people like this, which is why I've been so excited about the moon base.
Right. It matches so much. I mean, power is a backbone. I mean, you have to realize that power surface infrastructure and realize it early so you can continue to do the other asset, establishing them on the lunar surface. The site selection and the survey urgency,
really cool.
really securing the site, that also is very much in line with the moon-based plan. And then that early and firm long-term commitment is critical. So not only, that's why I emphasize that, not just going and being like, oh, we return humans on the moon. There is a plan to have an actual lasting presence on the lunar surface now. So really, we're very happy that they heard some of this feedback.
I mean, regardless, I also don't arbor any, like a lot of people can have ideas to do an experimental moon base. That's great too. But to see that the community wants this so much, and to see that NASA is responding to it was wonderful to hear. Right, the point that kept coming to me, that unified and consistent action over years, that's what industry really needs. And when they saw that possibility, we had quotes that they were saying that if we do this, this is the most exciting thing.
Right.
And this was still the more modest version of it, not the big.
Not admission. Nothing has happened this week. So just really cool. Very, very cool.
And to that point, this is where it's come now. I mean, it's also very clear to me that the NASA team that developed Ignition has been going out and listening to everybody that they possibly can so that they can make this the best version of a moon base possible, and all the other things that they're still trying to accomplish too, right? But the line that really stuck out to me was that they want to put every asset, every kilogram, all lunar exploration resources focused on building a moon base. So this is how you can take the individual elements that we're developing, turn them into something which is more than just the sum of their parts, right?
And all these individual components, the technologies needed, the development that they need, all of that conversation is going to take place at the LSIC spring meeting.
That's right.
That is happening at the end of April. So we've put a QR code there for you to take a moment and take a picture or look at it in your camera. We'll send the links of the LSIC spring meeting so you can see. But yeah, this is the most exciting time to be talking about this, and the meeting is happening in late April. It's like all stars aligning.
Yeah,
so great.
Really
so
nice.
Yes, please come and visit. We have a virtual component of the meeting. We have an in-person component of the meeting. Make sure that you're there, because all of these discussions are just completely timely, completely aligned with the national priorities.
Yeah, and we're going to have even breakout sessions, which are explicitly where NASA's coming to hear this community's perspective too.
Yeah, absolutely.
Mm-hmm.
All right, so with that, yes, I have only a few minutes, so I just want to say what exactly is the Lunar Surface Innovation Consortium, and it is that alliance between industry, government, academia, nonprofits. We harness the collective creativity, energy, resources of the U.S. to advance a sustainable lunar future. We have also international partners, everybody contributing to make sure that we are just addressing our goals. I want you to take a quick look at this slide. We hold over 250 monthly telecons on any topic you can imagine about lunar surface infrastructure, lunar surface technology. We have over 18 workshops right now recorded and accessible in our website, and over 10 biannual meetings also. And we're looking forward to our next biannual meeting that's happening in late April. Who are our members and participants? Over 4,000 participants, over 1,400 organizations, 50 states, including Washington, Guam, and Puerto Rico, and 70 plus countries. So this is really a massive community, and I am so honored and excited to be part of it. I cannot wait to see everybody in the spring meeting. And really, our community is very diverse. So we have industry makes 41%, but we have nonprofit, academia, government, enthusiasts. Everybody's just welcome, because this is the most exciting thing that we're doing right now. So what is the value really of being part of LSIC and going to LSIC meetings? It is really that interface with NASA. There are NASA people among the audience in the community. You can get access to funding opportunities. You can get access to partnerships and collaborations and a lot of people that have been in LSIC since day one are now the people that have all these missions and right. So they started with LSIC. So that could be also you. So it's just really incredible. I wanted to highlight our capability areas. We talk about cross-cutting capabilities, so anything related to logistics, mobility, extreme environments, the dust that people always talk about, all of that falls under the cross-cutting capabilities. In situ resource utilization, which would be of most interest to this community, all of those technologies are for collecting, processing, storing, and utilizing the resources on the lunar surface. Excavation and construction, which is all of those technologies that enable building, manufacturing, construction, etc., really manipulating that regolith to create other items that are going to be of use in this space. And then surface power. We've always mentioned that power is key. We really need power to then power all of the other assets that we describe in all of the other areas. So generation, management, distribution, and energy storage, all of those topics are covered in that capability area. We have tons of products, and you'll be able to see that, but we have a website where you can go and take a look. We have tons of different resources, including the community findings, our bi-monthly newsletter, and then our wiki site. So I saw somebody asking about a list of all of the rover lunar developers. We've done a rover study, so you probably can find that there as well. So it's Derek. We'll make sure that you have some resources for that. But anything you can think of, we've at least either asked about it to the community, touched on it. So we will be more than happy to make sure that you get all of those resources for you as well. Yeah,
and one interesting thing is that so much of this moves faster than we can even keep track of. So with respect to the rovers, there was announced just the day before yesterday that there would be a whole new slew of sort of different versions of LTVs that would be developed, and there's an RFI process out of that. So,
and now they're starting with just a more modest capability LTV, and then expanding to then the full power LTV. So it makes sense, because now you're just starting with something smaller, taking the risks, understanding the environment, understanding the system, and then building up to the bigger one.
I will say, keeping track of all the rovers is a hard thing to do.
It is right
all
now.
Of the category X is hard to do.
Oh my word, yeah.
It's only going to get harder too.
We will do our best, Derek, to give you the list of rowers, but we also have resources and places that you can also track that kind of information. Okay, I have to end, apparently, because we have to end at 2:45. So I just want to say, spring meeting. The spring meeting is happening. It's going to be amazing. We have an exciting program for everybody. It's going to be from April 28th to April 30th. The registration, if you go to that URL link, you should be able to go to the registration link and the agenda. But we are going to echo the nation's imperative and need for this immediate lasting presence and this infrastructure that is needed on the moon. So what are we going to do there? Panels on lunar surface infrastructure tech, follow up from Moon to Mars workshop breakout session. We're going to actually have a session with ESDMD, which is super exciting. What they need, right? We have a technology showcase with over 30 technologies coming. So that's incredible. Any updates, breakouts on sessions, and breakout sessions on ISRU, moon-based mobility needs, and of course, our community does tremendous work. So we'll be able to let them show their work with poster sessions and lightning talks.
Yeah,
so
almost 100 posters in total, or is it over?
We had over 100 abstract submissions, and then we were just
so a few virtual, but a lot in person. So
a lot of in person and a lot of virtual as well. So there's always a virtual component with LSIC. So. All right, so that's really what we wanted to talk about. To the moon with LSIC, LSII, all of us together working towards the moon. So. Thank you.
Thank you.
Wonderful. Thank you guys. Really interesting stuff. And I mean, I'm one of those people that's been an LSIC member since nearly day one. It has been amazing to see how you guys and your team have scaled this to really meet the needs of the community at that intersection of exploration, tech, and science. So as someone who tries to operate at that interface, thank you for all of this, to you and everybody else who's ever been involved, including the members of LSIC. I think this is a great community resource. So FYI, everybody, I did put a bunch of the links that the LSIC team who is in attendance sent in the chat. It turns out the chat that you attendees can only send chat to hosts and panelists. And I was apparently not doing a sufficient enough job of keeping an eye on if everyone was receiving those. So all of the links that were discussed for LSIC's website, the LSIC sign up, the papers that they discussed, the spring meeting registration link, the different events, and all of the focus areas of LSIC are in the chat. So they're all there. Sorry, I got them there a little late. And right now, to add more links into the mix, I am going to add links to the AIAA Space Resources webinar, the Space Resources Technical Committee's YouTube channel, as well as the AIAA Engage page. We do of course, the YouTube videos are free to watch, and the slides that we post on the AIAA Engage page, that rhymed, they are free also. You do need to have an account, so you do need to sign up with AIAA, but you do not need to pay dues to access these, for example. So you enter your email address, create an account, and you'll be able to access those slides. If there's any issues, please let me know. But now enough from me for now. Ali Kaduri says, I have made a professional satellite apps over multiple ground segment. I would like to participate in one of the webinars presented. The app is also useful for satellite operators, and I'm also an operator.
Excellent.
So if anyone's interested in that.
I wonder if that would fall under economy topics or, Okay, if you leave your contact, Ali, we can figure out. Yep.
Hey, Dallas.
He's responding to Derek, which is nice.
responding
Before has
to.
Perfect.
any robots that we plan to modify for the moon and Mars. Ooh, exciting.
And here is that, where did that go?
Oh, that's in
The
the
sub
Q&A.
the
In the
satellite app
Q&A,
that
Yeah.
Ali mentioned.
Very
And then
cool.
in the Q&A, earlier, as Melina and Wes pointed out, Derek Goyton said, I work at Relativity Space. We are looking for a list of all the lunar rover developers, and you, Derek, you came to the right place. Dallas Bienhoff also said, Derek, Offworld has Earth mining robots that we plan to modify for the moon and Mars. There are a lot of groups doing this. Interestingly enough, I'm going to give a shameless plug for one of the groups that I'm working with that does this, the American Society of Civil Engineers,
Oh,
ASCE.
Yep.
I'm one of the leads of the Regolith Operations, Mobility, and Robotics Technical Committees, and we are also looking into compiling a list of the American-made mobility systems. Some of our NASA colleagues were restricted to using US made, US available things in their studies. And it's nothing like TRL6 Moon ready to go, but for lab development, like simple mobility systems. So we as researchers don't need to spend our time and effort developing the mobility system just to test a sensor that we've already developed, kind of thing. So if anyone's interested in that, please don't hesitate to reach out. Derek in the Q&A said, Derek, can I share this email address publicly in the chat? I'm not going to until you say yes. So
While you I was wondering if you saw all the regolith ops in the moon base announcement. It's all over.
Yes, it is. And it was really cool to see a lot of the groups that were highlighted doing that. I know the KSC Swampworks crew is big supporters and involvement in LSIC, and
absolutely,
I saw a lot of their work featured in those clips. Really cool to see.
Yeah.
Okay,
I wanted to mention, I really love what I think it was Dallas mentioned. This is one of the reasons why we did the Lunar Engineering 101 materials. There was a lot of companies that were
terrestrial,
really, right?
Yeah.
That were coming to us and say, hey, I work on projects really for the Navy, but I think my technology would be applicable for a lunar application. How do I transition my technology so it is adequate for the moon?
Mm-hmm.
And so a lot of people were coming to us, really, asking us these questions, and the environments are completely different. So getting those considerations and making sure that they understood what are the key differences to design for really was helpful.
Yeah.
And so anybody that is in a company that's doing terrestrial stuff or maritime stuff, if you go to Lunar Engineering 101 and learn about the environments, you might be able to then cross some T's, dot some I's related to how to transition the technology for the environment of the moon.
Exactly. So I've shared Derek's email, and in the Q&A, he says, I'm looking for a rover partner to substantiate our welding additive manufacturing system.
Oh, very cool.
Relativity Space builds the world's largest 3D printed rocket, and we have a Hive Swarm mobile robotic inspection, welding, repair, and printing system that they're developing for terrestrial applications and are looking for a rover partner.
Derek, you sound like the perfect candidate for being an attendee to the L6 Spring meet. So you should make sure. I mean, if you can only attend virtually, just register. There's going to be lots of people there as well. But if you come in person, there's a lot more opportunity to be able to connect with some people.
I mean, I've been tracking Relativity Space for a while, so I'm very interested in hearing like what your thoughts are, how to transition that. So, yeah.
Very, very exciting.
Yeah, I mean, monitoring, assessing. Well, what else do you have in there? Manufacturing, not that. There was another.
Oh, look how sweet. I love you guys.
Thanks, Garrett.
Very cool. Yeah, I think he put here what was the
what it was. Inspection, welding. I mean, that's something that we had thought about too, is if you have a robotic moon base, how are you autonomously not just deploying the stuff, but inspecting it as well? So you know what you need to improve the next time, or if it's working out, or where there might be changes you need to take. You're not going to go necessarily immediately to go send humans to go inspect every one of these landings.
But you might be able to immediately identify the need for a repair or something, because according to Carlos yesterday, the moon base, I think he's the moon base lead for NASA, they're going to have a live stream of
A
the moon
live stream,
base.
yeah, they want to have a
So,
lot of video.
there's a
things
structure
happening.
that needs a little welding, a little repair. We'll be able to see
Check
it.
it
It's
out.
just
Yeah.
really incredible.
Very cool.
Yep.
Very cool.
And
Check it out.
so I do have one question that I want to kick in. So a lot of I'm an academic, and but a lot of academics uh tend to, and I don't want to speak for everybody, but
Yeah.
in academia, it tends to be there's an initial hurdle to interfacing with industry partners. I was wondering if you guys could comment on any mechanisms, any methods, any general approaches that you've seen that generally enable the more siloed academics, I'll admit, to engage with this broader and industry, engineering, government, exploration-oriented community.
Yeah, there are a handful of solicitations that allow or even encourage a lot of those partnerships. I think the question is, as you said, what gets you across the hurdle?
Right.
Mhm.
I mean, maybe hopefully this isn't, just an answer that's obvious, but making those connections really matters, right? So you need to find ways that you're actually speaking to those industry partners that you might have. And that's often like many interactions that you have to do before you get there.
Right.
But I would say, one of the biggest hurdles that we've seen for lunar stuff has always just been, how do you get access to space even? So the opportunities for an academic to participate were limited because you had just very few opportunities to do it. And now with the increased cadence of those landings, one of the things that I'm seeing coming down the road that we're barreling straight towards is, we're going to run out of payloads. And so the opportunity to fly things that are riskier or that are a little bit more early, not as quite, I think that those opportunities are going to get more and more. And we did hear that there was interest explicitly in understanding how academia can participate in this moon base development as well. Right. So I think that that's going to be addressed directly by the administrator, but if you're looking at what you can do right now, it's actually just making those connections.
Right. I agree. Now, I will say, we were part of the academia world many
we have
years.
EDU addresses, technically.
Exactly.
Yeah, that's
ago.
true.
And you remember those proposals, and you remember all of the details.
much
I mean,
fun,
there's a lot of early research that is done for something. When you approach industry, perhaps what needs to be done is say, this is all the stuff completed, and this is the technology that we have ready for you to consider. Have a one-pager that says, this is how much mass it would take, this is how it could be attached to your lander, and this is what it can do. If you have something short like that, and you say, we have tested it for outgassing, we have tested it for, I don't know, vibe, it can hold this many loads, or etc. If you are able to provide that information to somebody that is a lander provider, for example, they might be able to say, I can actually fit this between camera A and, I don't know, antenna B. I just think that if academia were to approach people with the actual technology specs that they really want, regardless, you are the one that is assuming that you want to demonstrate, so it's going to be high risk. But if you give that company exactly what you are pitching without all of the details on the research side, I just think that they might be more open to really hearing the how can they incorporate them in their technology. And you know how many rovers and how many landers are going now to the moon? I mean, you can find space for your technology. I mean, seriously.
Now it seems like it.
Absolutely.
Yeah.
I am looking forward to hearing if they're going to update some of the acquisition strategies. So there was a bill that came out not too long ago that said, this is our strategy and this is sort of the class for how we want to acquire things. So that could also give some opportunities for us to understand where academia plays.
Absolutely. Yeah. I just think there's room for every player. The United States is not going to be able to achieve this ambitious and accelerated goal without everybody being a key player into this. Academia has a big role in this, for sure. In the scientific exploration and understanding. I mean, you're putting infrastructure on the moon and you haven't understood yet really what happens when you put an asset there and it has been there for a year, 2 years. The scientists are really the ones that are going to look into that with the help of the technologists.
Yeah.
So I think there's space for everybody to have a good and important contribution. And this is our community, so.
The pipeline too, like it starts with academia. So I can imagine too, as they're running out of higher TRL payloads, the reach back in coming in that way. So I don't know, it's going to be an interesting time. It might be worth it for us to. There's an RFI out
And
right
Dallas
now
has,
for
yeah,
lunar
thank
payloads.
you.
Exactly
Absolutely.
right. Yep,
So,
exactly.
and who develops those technologies, but with the key insight and the key design of that scientist that's really telling you how do you learn about XYZ, about the moon. So it's really that I just think academia has a role. That's my.
I'm biased, but I do agree.
I maybe do, but I know I speak true.
Yeah.
You do. Okay, so we're getting close to the end here. I just put in the chat for everybody the link to the AIAA Engage page and the YouTube page where this talk will be available for anyone who didn't make time in their schedule for this amazing event. I can't believe the audacity. Anyhow, I guess we can start to close. I don't see anything else in the Q&A that hasn't been addressed.
Just
There's
want to
nothing
thank
else in the chat.
everybody that's what's able to make it. We really appreciate it. We hope to see you at the L6 Spring meeting, whether in person or virtually. I really, really hope to see you. And hopefully we were able to share the enthusiasm with you, and you also have all of the exciting things that are happening with the moon. And yeah, we are over the moon, above the moon, and we are going to the moon. So very happy. Yeah.
And thank you guys for taking the time to present all this and brief our community on everything that you and your team offer. I look forward to seeing you two as well as anybody else that can make it to the spring meeting in just in just about a month actually.
And register,
hopefully
please register. My operations lead here is telling register.
exactly.
Thank you.
So I hope to see you all there. And I look forward to seeing many of you next month on our next at the spring meeting and on next month's webinar.
Fantastic.
So Milena, Wes, thank you again. It's been a pleasure.
Thank you.
Great.
Take care. Have a good day, everybody.
Bye, everyone.
Bye.